So let us start our today's session on linear programming. This is an introductory session as well as syllabus coverage both. So in this, I want to cover the following aspects to everyone. First, cover the following aspects. What is the syllabus? And time for the coverage of syllabi for this particular topic. And exam point of view, what are the topics to be covered or taken care of, then books to refer, and if any you have, and as well as the weightage with regard to the examination point of view. Right? So welcome to everyone. So do you have any other queries from your side? Say any other queries to anyone? So this part will come under paper 2 of maths optional. Yeah. Is it fine now? Thank you. So any other queries to anyone for this apart from these things? Usually these are the frequently asked questions from students. If you have any other questions, you can ask. Thank you. So let me go with the syllabus first. Syllabus is very simple. Linear programming problems, basic solution, basic feasible solution, optimal solution, graphical method, simplex method of solutions, duality, transportation, and assignment problems. So if the syllabus is with you, it is okay. Otherwise, please take a note of that, or you can take a photograph of it. Fine. So after noting, you please inform. Right. So after this syllabus, the time for the coverage of this total syllabus is 15 hours. I will say the class discussion of 15 hours is enough to coverage the concepts of all these syllabi. Apart from this, we can discuss so many hours with regard to the previous year questions and other doubts whatever you have. Fine. So number of hours is not a constraint. The minimum number of hours required for this is 15 hours. That is what I am to say. The advantage of this topic is it is very easily scorable compared to UPSC examinations. And the only typical thing in this part is the calculation of the equations. That is the only difficulty. So because no higher end logical thinking is not involved in solving these problems. So the only concept is we have a basic formula. You are going to apply the formula for one particular problem, and the difficulty lies in calculating the steps. That is why it is very important and very easy to understand and solve the problems based on linear programming in civil service exams. Fine. And with regard to examination point of view, the problems or concepts what we are going to concentrate on the transportation method and simplex method. So majority of the questions are posed under these concepts. However, assignment problem is also there. So if you check with the frequency of questions asked on a particular concept, they are mainly based on simplex method problems and transportation problems. Fine. Is it clear to all? Right. Now, so coming for the books which we need to follow. Yeah, I will go. Each unit has equal weightage. So the minimum weightage is 50 marks. And obviously, whenever a question is posed on simplex method, usually the weightage will be for 20 marks, and as well as for transportation problems, the weightage will be 20 marks in general, or the least weightage for a particular question is 15 marks. Under compulsory part section, that is section B, the minimum weightage will be 10 marks. Or else, each unit has equal weightage. In general, 50 marks you can expect from this part. Fine. So coming for books, there are so many books available. So for one to start afresh, so if you are reading for the first time or learning for the first time this subject, the language should be convenient and it is easily to solve a problem. So that I will refer the following books. You can take any one of them. Operations research by the following authors. One book author is Paneer Selvam, published by Prentice Hall of India. Another one, V.K. Kapoor, by Sultan Chand Publications or S. Chand Publications. And one thing by R.D. Sharma. One book is taken from Colonel D.S. Shima. CHE. There are many other books available on it also on operations research. You can find a book on the other Lieberman. Another book is there by Taha. If you have the engineering mathematics book by B.S. Grewal, there also you can have the concept of this linear programming, not transportation assignment problems in detail. For linear programming, it is okay. B.S. Grewal. So among all these books, one book is sufficient for you to learn the concept. Later on, you are going to practice all the previous year questions based upon the class discussion. That is enough for the preparation as far it is concerned. Fine. That is also you can follow. You have a lot of books available. I am mentioning one among them, whichever is nearest to you for purchase. The only thing is you are going to learn some of the concepts from these books to solve a particular problem. Later on, you are going to solve all the previous year questions based upon your knowledge and discussion of the classes. That's it. If you are able to solve all the previous year questions, then our preparation is completed as far as the exam point of view is concerned. Fine. That's it. So any other queries for anybody? If everyone is clear with this, I will start the syllabi. Right. I think I have answered all the major questions which you want. I hope so. Thank you. So let us start the syllabi. So linear programming is usually a mathematical technique which is useful to solve a particular type of task. So let me say, if I am a business person, I am doing a business. So my objective is to maximize my profit. If I am a person who belongs to the transport department, then my objective is to minimize the cost of transport. Am I correct? So the whole idea of task is nothing but maximizing or minimizing. So for a given set of data or a real life situation what you are practically facing, we are going to build a mathematical problem whose objective is to get the maximum value or the maximum solution for the problem and minimum. So which we generally call it as the linear programming concept. Accepted? So in which to solve the particular task, we use several methods. One of them are graphical method, simplex method, and etc. And this session is dedicated for how to formulate a problem, and second, the solution criteria, and third, the method, we call it as the graphical method, which is used to solve the linear programming problem, simply LPP, linear programming problem. Is it clear to all? Any questions you have? Shall I proceed? Thank you. So first of all, may I know how many of you have the prior knowledge about this concept? Or all of you are learning for the first time? So please post your fine. Right. So I will start afresh right from the beginning to everyone. So these three things are today's session criteria. Fine. Formulation of LP problem, solution criteria, and graphical method. So I want to give a set of data for you now. So since it takes time to write the entire content on board, I will give the maximum representation on board for the data, and I will explain the content also. So I will just take the following. This was the question. So I have a company which manufactures two products, say P1 and P2. Now, to manufacture these products, every product has to undergo a process by means of machinery, right? Yes or no? Fine. So here the thing is, I am going to give the detail of the machinery as well as the process procedure. So this is the tabular data given for it. Products P1 and P2. So which has to go for two machines. First one is the lathe machine, another one is the milling machine. The time taken for it is 5 hours and 4 hours, and for this is 10 hours and 4 hours. And machine hours limit for the first one it is 60 and this is the 40. And the profit is, for the first product, let me say I got 6 rupees as profit, and for the second machine, the second product, I got 8 rupees as profit. So this is the data given in the problem. I have written completely on board. Right? Now, after seeing this problem, what we need to understand? And if you formulate this data into a mathematical problem, how it looks like? Is the task clear to everyone? How we are formulating an LP problem? Right. So here what happens, on observing this set of data, the first thing is every LP problem should have the objective. What is the objective for this problem? The only concept of LP is either to maximize or minimize. So the concept here is maximization, because I know if I sell the product P1, I will get 6 rupees profit. If I sell the product P2, I will get 8 rupees profit. So if I am a business person, my objective is nothing but maximization of profit. Do you accept? Any queries for anybody? Right. So we are going to build some set of constraints which are based on this tabular data. So the thing is, I have to manufacture the products P1 and P2. So I will take two variables x1 and x2 such that x1 is meant for number of units of product P1 and x2 is meant for number of units of product P2 to be manufactured. Accepted all? Yes or no? because at each step I want to take the confirmation from your side so that I can better understand in what way I am going. So I am going to write the objective as, my objective is I have to maximize the profit on manufacturing the two products P1 and P2. So if I sell 1 unit of P1, I will get 6 rupees as profit. Since I am manufacturing X1 units of P1, so I will get 6x1 as my profit. Similarly, if I sell 1 item of P2, I will get 8 rupees as profit. Since I am manufacturing total X2 number of P2, so I will get 8x2 as profit. I am manufacturing both the things, so if I sum up these two values, this is my total profit. Accepted? So our objective is maximize profit 6x1 plus 8x2. So usually we use this as maximum Z is equal to 6x1 plus 8x2. Now we are going to build the set of constraints for the variables x1 and x2. The variables in this objective function are called decision variables. So decision variable is nothing but which performs an activity, right? So I am going to build the constraints for this. So please understand that if I want to manufacture P1, it must undergo two stages. One is mission 1 and mission 2, lathe mission and milling mission. Similarly, for P2 also you have two stages, and at each stage I have mentioned how many working hours are required. Is it clear? And for each mission, whatever the product you manufacture, you cannot exceed the maximum limit of hours like this, 60 and 40. So you can use the mission 1 at most 60 hours, whatever the product you manufacture, either P1 or P2. So I will write the constraint as 5x1 plus 10x2 is less than or equal to 60, because you cannot exceed maximum limit, that is 60 hours. X1 stands for number of P1, X2 stands for number of P2. So this is machine hours. So 1 unit requires 5 hours here, 1 unit requires 10 hours here. So this is total hours, 5x1, 10x2. This we call it as time constraint. Similarly, for the second stage also, you have 4x1 plus 4x2 is less than or equal to 40. And we are building the number of units. It is always a non-negative value. So we say that x1 is greater than or equal to 0 and x2 is greater than or equal to 0. Either you can stop producing a product or you can take a number of products to be manufactured. It cannot be a negative value. Accept it all? Any queries for anybody with regard to building up these constraints? Fine. Then let us write in the mathematical way. So if you write it formally, x1 stands for number of units of product P1 and x2 stands for number of units of product P2 to be manufactured, and maximum z equals to 6x1 plus 8x2 subject to the conditions 5x1 plus 10x2 is less than or equal to 60, 4x1 plus 4x2 is less than or equal to 40, where x1 greater than or equal to 0 and x2 greater than or equal to 0. This is the mathematical formulation of LP problem. So please check on that. So whatever the linear programming problem we take usually it looks like this. What the variable stands for and what are the constraints we are taking and what is our objective. So on looking at a linear programming problem, we have to identify that it has an objective function. In the objective function, we have the decision variables, and for decision variables, there is a constraints. So what are the decision variable constraints we are going to identify? Then for every variable, it performs some activity, so it undergoes a process. So it has to satisfy some set of constraints. So these are the constraints, and these constraints are extracted from the data with regard to the real life problem what we have taken. Clear? If it is clear, then I will go for another problems, so that we are going to formulate LP problems for the given set of data. With regard to the examination point of view, we have less focus in formulating LP problem because everyone know how to formulate the LP on seeing the given set of data. So the difficulty is a question will be asked to solve a problem using graphical method, and there this formulation is not at all given. So you have to formulate the problem and you are going to solve it by means of graphical method. That is the maximum difficulty you are going to expect in the examination point of view. And the difficulty arises as and when the number of constraints increases and the number of variables increases. That is the thing. So at most complexity is 3 variables you can expect and 3 to 4 constraints you can expect for formulating a problem. So shall I continue with the other modules? Right. I am going to erase this. May I? Thank you. So let us take a similar kind of question. So I have a company which manufactures 3 products, say P1, P2, P3. Similarly, I am going to give the respective machine hours and labor hours to produce these products and maximum available hours for it in the form of a tabular data. So machine 1, 2, 3, labor for product P1, P2, P3. Since it was written, I will take like this. So 4, 6, 3. And maximum hours available is 500, 300, 600 and 200. And at the end, it is given that selling price of the unit is 500, 400, 550, and product cost, unit product cost, I will say 350, 280, and 390. So please look at the problem. So since you have an initial idea how to formulate it, let us go with the solution part. So after noting this, you please inform. So what is the variation compared to the previous problem and this? There you have only two products, here three. Yes, in the previous one, profit is given straight away. Here, apart from profit, he has mentioned for one single unit, what is the selling price and product cost. So the difference of these two will give the profit, isn't it? So if we extend the table, from this we can say that the difference of these two is 150. Here you have 120. Here you have 160. So this was the profit. Accepted all? So usually for this type of tabular data, so usually X1 stands for number of units of P1 to be manufactured, X2 for P2, and X3 for P3. So you just simply take it as a matrix. These are the constraints. Since it is the maximum availability of hours, you are simply writing like this. So in a nutshell, our objective is nothing but maximization of profit. So we simply write that maximum Z is equals to 150 X1 plus 120 X2 plus 160 X3. Is it visible on the top or not? Yeah. So subject to the constraints, you simply write that 4x1 plus 6x2 plus 3x3 is less than or equal to 500. 3x1 plus 2x3 is less than or equal to 300. 5x1 plus 7x2 plus 8x3 is less than or equal to 600. And 3x1 plus 2x2 plus 4x3 is less than or equal to 200. These are the constraints. So any doubts for anybody? There is the formulation of LP. So can I take the other one, which is a little variate? Fine. So after noting this, you please inform. If you are interested in formulating the LP things, I will give a set of questions as a daily practice today or tomorrow or in the upcoming sessions. So you can formulate the LP problem for the real life situation. Fine. We can discuss more on that. So let us take the other one. Just hold on a second. So this question is about manpower scheduling problem. I will give the objective there. So just take that you have a multi-specialty hospital where for every 4 hours a person is to report. That means he is attending the duty. Every person must report at 4 hours. In other words, for every 4 hours, a person is coming and reporting to his duty. And his duty is 8 hours. As and when he reports to duty, he has to work continuously for 8 hours. That is nothing but the shift. And I am going to give the time slots. So our question is, how many number of persons are required? This is the objective. Clear? I will give the tabular data. Is the objective clear for everyone? Fine. Now I am going to tabular data that. I will erase that. So this is time interval 1, 2, 3, 4, 5, 6. We have the time period from to given by 12 midnight to 4 a.m. Then 4 a.m. to 8 a.m. (8 a.m. to 12 noon), 12 noon to 4 p.m., 4 p.m. to 8 p.m., and 8 p.m. to 12 midnight. Because for every 4 hours, person has to report. In a day, we have 24 hours, so we will get 6 time intervals. And minimum number of persons required is given by 20, 25, 32, so I will say 35, 32, 22, 35, 32, 22, and 15. Now, please read the question. I think the data is clear to you and the objective is clear to you. And how to write the decision variable here. Are you getting the context or not? Say yes or no. Yeah. The question is, in a multi-specialty hospital, for every 4 hours, persons will come and report. As and when a person reports, he will work continuously for 8 hours. Right? So, this is the tabular data available for persons as well as the time slots. The question is, we have to find the minimum number of persons required. That means to satisfy all these time constraints and all these person constraints, how many number of persons I have to recruit? Clear now the objective? Yeah. Anybody has any other queries? Yeah. Any inputs from your side? So if you just simplify the task, suppose we have a house, there are different persons working for it, cooking, washing, housekeeping, etc., etc. So how many number of persons are required to fulfill all the works? Just like how many number of persons required to satisfy minimum number of persons wanted for each time interval, and 8-hour shift, and every 4 hours person has to come and report. Is it clear now? Yeah. So can I go with the solution then? How to formulate this into mathematically? So since there are 6 time intervals, I will take 6 decision variables: x1, x2, x3, x4, x5, x6. So what they indicate, x1 indicates the number of persons reporting at 12 midnight. X2 indicates the number of persons reporting at 4 a.m. Similarly, 8, 12, 4, 8. So the number of persons reporting at the beginning of the interval stands for the decision variable. Accepted? Yes or no? So I am going to build up the constraints now. So this is x1, x2, x3, x4, x5, x6. Please understand that as and when a person enters for the first interval, he is continuously working for 8 hours. It means that he will work for the first interval as well as second interval, isn't it? Because the interval slot is just for 4 hours only, but the person is working for 8 hours. So if you take that, the interval 5, in interval 5, who are the persons working? X5 and X4, isn't it? Because this person is working for 8 hours, so he will continue in this time slot also, and this person is reported at this time slot, so right from here onwards he is going to working. Is the context clear to everyone? Any questions? Right. So let me say, let us generalize this. Suppose 2 persons are reported at x4. I mean at the time interval 4. What does it mean? They started working for 12. They started working at 12 noon, and they are continuously working for 8 hours, right? So they will work for 2 4-hour slot. That is the slot where they have entered and the next slot also, isn't it? Because 8 hours is the shift time. So if you say that x4 stands for number of persons entering at this interval, means so at the 4th interval x4 number of persons are working, and these are continued for 5th interval also. Say yes or no? Similarly with the other cases also. So what happened here? So if you set up a constraint for interval 5, here x5 number of persons entered, previous interval persons are also working here, so the total number of persons are nothing but x4 plus x5, isn't it? So at time interval 5, these are the total number of persons working. Accepted. Now what is the constant here? The minimum number of persons required for this time slot is 22. So if you sum up the total number of persons, it must be greater than or equal to 22. Accepted all. Any other queries? Similarly, if you take the sixth interval, what are the persons decision variables working? X6 and X5. So X5 plus X6 is greater than or equal to 15. So if you take the first one, X1 persons are working and X6 are continue to work here. So X1 plus X6 is greater than or equal to 20. So like this we are framing the constraints. Accepted all. Say yes or no. So if this context is clear, I will write straight away the mathematical part. Shall I? Fine. So why I am taking these problems means to get an interest that how linear programming is connected in our real life and how we are getting solutions for real life situations with regard to the linear programming concept. That is the main motto. So our task is we want to find the minimum number of persons required for all the time slots. So x1 plus x2 plus x3 plus x4 plus x5 plus x6. It stands for the total number of persons required for all time slots. So for the interval 1, you have x1 plus x6 is greater than or equal to. For interval 2, x2 plus x1 is greater than or equal to. x2 plus x1, x3 plus x2, x4 plus x3, x5 plus x4 and x6 plus x5 is greater than or equal to, given by the conditions that 20, 25, 35, 32, 22, 15. This is the mathematical formulation of the problem. Did all of you accept for this? Right. So since you know how to formulate the mathematical problem, now I am going to discuss about the solution part. How we are solving a linear programming problem by means of the graphical method. Graphical method is nothing but simply drawing a graph so that we are finding the points in the coordinates, so which satisfies the given set of constraints. That is the thing. So do you need more examples in framing the LP part? Say. Right. So if anybody wants to frame more LP problems like this, I will give a set of practice exercises for you if you are interested. Thank you. So can I go with the solution part right now? Because if you want to get still more interest towards framing the problem, I will take more number of problems as per your wish. This is up to you. The class session is up to you. Okay, I will go with the solution part then. Now see, for a linear programming problem, there are different solutions available. First one is feasible solution. what is meant by a feasible solution? It is just like, since you have framed a set of constraints for the given problem, on that you are going to determine the values of x1, x2, x3 which satisfy the set of conditions, isn't it? Say yes or no. So what happens here? So if you find a set of values which satisfy all the criteria of the conditions, we call them as the feasible solution. A solution which satisfies all the criteria of all conditions, we call it as a feasible solution. Also we call it as the basic feasible solution, because which is the basic solution. Now then we go for the optimal solution. Optimal solution means among all the values of xyz, which gives the best result for objective function z. Usually we denote with the symbol z. Okay? Yes or no? Right. So later on we will have the other cases like unbounded solution, alternate optimum solution, and infeasible solution. So alternate optimum means you have more than one solution which gives the maximum value of z. In other words, let me say the maximum value of z is 100 if the objective function is maximum z. So this 100 is obtained by two different set of values or two or more number of values of xyz, which gives the answer 100, 100, 100. So in such case we call it as alternate optimum solution. Okay? So unbounded solution means in some situations, even though we have the maximum value of z, we have a possibility that you can get the z value as infinite. It has a possibility to get unboundedness for the solution. And infeasible solution means no solution. So you cannot find the set of values of xyz which satisfies all the criteria of the conditions. Accepted? So this is about the solution part. What are the solutions available for the LP model? So I am going to take the final stage, that is graphical method for solving a LP problem. Shall I? Right. I will take the first problem now. solve the LP using graphical method. So it is given as, let us take the first problem, what we have taken there, and we have formulated. Subject to the conditions (5x1 plus 10x2 is less than or equal to 60) and 4x1 plus 4x2 is less than or equal to 40, where x1 comma x2 are greater than or equal to 0. So please note down the problem. This is our first problem of the discussion, which we have formulated, and we are going to find its solution. Right. So now let us draw the graph. Usually the graph contains x-axis and y-axis and origin. So here what happens, depending upon the decision variables, we give the name. So x-axis we take it as x1 and y-axis we take it as x2. Now you know how to write or how to draw the graph of an inequality, right? So less than or equal to indicates that if you take the straight line 5x1 plus 10x2 equal to 60, you draw the straight line graph here. Since it is less than or equal to, so all the values of x1 and x2 which satisfy less than or equal to 60 will come under this line. Accepted? Right. So just give me the point sorry, just give me the points that at where this straight line cuts the axis. So if you put x2 equal to 0, what will be x1? 12, and another one is 6, right? So let us draw that. Say 1, 2, 3, 4, 5. Let us extend this also. I think it is better to take two values rather than single. So here, by putting x2 equal to 0 and x1 equal to 0 here, you get the corresponding points as, this is 12, 0 and 0, 6. This is the graph of this line. Accepted? So every point below this line satisfy this criteria. You can take any x1 and x2 below this line, they will satisfy less than or equal to 60, 5x1 plus 10x2. Say yes or no. In other words, whenever less than or equal to is there, you draw the straight line and shade the portion towards the origin. And whenever greater than or equal to is there, you draw the straight line and shade the region away from the origin. Right. And for this, what are the coordinates? They meet the coordinate axis by putting x1 equal to 0 and x2 equal to 0, 10, 10. So you draw the line like this. This is 10 and this is 10. And we are pairing all the lines before this. Now what happens? You are going to pick up the values of x1 comma x2 which satisfy both the conditions. That means you are picking the points which are below the two lines. So this will be the feasible region. Because if you take a point here, it satisfies this criteria only and it is not satisfied by this point. Accepted? Because the condition is less than or equal to. Fine. So usually whenever an LP problem gets a unique solution, always you will get a polytope or polygon, we can call. A closed polygon usually we will get. And always remember that the region always lies in the first quadrant. Why? Because always the variables take non-negative values. X1, X2 are always greater than or equal to 0. Even though the line extends so much, you cannot take the values of the other quadrants because we have the non-negative restriction on the variables. So always the feasible region comes under the part of first quadrant only. So this is the feasible region. So usually every point in this region satisfies these two conditions. So it is a solution. So among all these points, which point gives the maximum value of Z is nothing but the optimal solution which we are going to find. Clear? Any queries? Right. Now what happens? There is a saying that, or a result, always the maximum value comes at the corner points. So what are the corner points here? Please understand, while taking the corner points, we are taking which satisfies the criteria of the conditions. So I am not taking this point. I am taking the feasible region, the polygon corner points. We always leave the origin because always origin gives the minimum solution. So here the point is 0, 6, one point is 12, 0, and one point is formed with the intersection of these two lines. So by simply solving these two straight line equations, you will get the point of intersection. So it is nothing but 8, 2. I think everyone know how to find the point of intersection. Am I correct? Fine. Now we are going to substitute these three values in this objective function. You can give technically names as A, B, and C. And we are going to substitute the maximum value from the values. So if you substitute 6, 0, Z equals 36. It is, I think, 0, 6. So Z equals 48. If you substitute 12, 0, Z equals 72. If you substitute 8, 2, Z equals to, what is the value there? By substituting 8 and 2, 64. So among all these, which point gives the maximum solution? Right? So you are going to understand that whether we have considered all the points correctly or not, we should need to consider. Now tell me, is 12, 0 is a point acceptable or not? Why? Because if you take a point, it must be before this. So this is the point 10, 0, right? So we are substituting 10, 0. It will be 60. Accepted now? All of you. Fine. So among these, which one gives the maximum result? 64, obviously, given by the point 8, 2. So x1 is equal to 8 and x2 is equal to 2 and maximum z is equal to 64 is our solution. So this is the procedure usually we solve with the graphical method. Clear now? If the solution part is clear, I am going to take the other one. Can I erase this? So from this observation, what are the limits for graphical method? Can you say? Because the solution always comes at the corner points of the polygon. Usually the maximum z occurs at the corner points of the polygon. Fine. Right. There is another approach that suppose you have a polygon, say this is the feasible region. So in this, every point is a solution. So what happens if you randomly pick up a point here and a point here, you will get a straight line. So for this, we will draw the iso profit lines or iso cost lines, nothing but a line which is parallel to this, and we are going to extend like this. So what happens? It meets the feasible region at some particular point, exactly at one place, let me say. So at that point, usually we will get the maximum z. And usually that point will be at the corner point. The thing is, this method is useful to find, but the complexity is there. If the feasible region is not in a good shape, drawing these iso profit lines will become somewhat difficult. Let me say, if this is the feasible region, so what does it mean? Any point or every point on this region is a solution of the LP problem. Say yes or no? Right. So you randomly pick up a solution taken on the axis at this one point, you will get a straight line. Now you are going to draw a parallel line. We call it as iso, similar. So iso line, and you are going to extend like this. You are extending this iso profit line. So it meets the feasible region at the end at exactly one point. We will take care of that. Sometimes it meets at 2 points, but always it meets exactly at one point. So that at that point you will get the maximum value of z or the minimum value of z, whatever it is. That is one method, but which we generally not use while solving the problem by means of graphical method. Because always the solution lies at the corner points, so that by corner point method only we solve the problem. So this method generally we won't use. Okay. The typical thing here is, if the region is not in a good shape, drawing these parallel lines become somewhat confusion. So you cannot get a straight line alignment, so you will miss the solution. Accepted. So this technique we generally not in use. Fine. Do you have any more doubts? You can start like anything. You can start like this also. This is also accepted. There is the question here. That's why we stop this approach. So in practical, it will not yield a good result. That's why we go with the corner point method always. Clear now? Right. So let us take the other one. Minimum z equals to 2x1 plus 3x2 subject to the constraints x1 plus x2 greater than or equal to 6 and 7x1 plus x2 is greater than or equal to 14, and where x1 and x2 are greater than or equal to 0. I think you are able to draw the graph for it. Accepted? Can you? Say. Are you with me? Fine. So let us draw the graph x1 and x2. So can you give the points for the first one? 6, 0 and 0, 6, isn't it? Right? So you can take obviously 2, 4 and 6. The straight line comes like this, and since it is greater than or equal to, the points are coming upwards. Accepted all? Now give me the coordinates for the second line equation. 7x1 plus 7x2 is greater than or equal to 14. Yes, 2, 0 and 0, 14. So it will be, if we extend this, say 8, 10, 12, 14, it will come like this. So this will be the feasible region, right? Any questions for anybody in drawing these graphs? Fine. Now, if you look at the points, so what are the points we need to take? 6, 0, 0, 14, an intersection of these two. What is that value? Can you say? Solving the two equations. Yes, 4 by 3 and 14 by 3. This is the intersection point. Now you are going to substitute these three values in the objective function and you are going to get the result. So for the first one, the result is Z 12, and for this one 42, and for the last, what is the value? It will be 16 point something, I mean the 50 by 3. . . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 So among which, since the objectivity is to take the minimum value of z, among which the minimum value is 12 taken here at 6, 0. Accepted? Right. Now at this problem, we can observe that the solution space is unbounded. Say, so if the same question is taken for maximization, now what happens? The solution is unbounded, so you can say that it tends to infinity. That is what I am going to say. We have the possibility of unbounded solution, because it is not possible to calculate the points which are moving away from this, right? We cannot depict. Say yes or no. So at that point, we say that the corner points gives the solution, among which the maximum is 42. We can say that the maximum value of z is 42, but it has the possibility of becoming infinity also. Such type of solutions are called unbounded solutions, where the feasible region is not at all bounded. It is open region, not a closed region like a polygon. I think this makes sense for everyone in getting the solution ideology. So since the timing is running out, let us wind up our session here. Tomorrow I am going to come up with more problems on graphical method as well as simplex, so we can have a more discussion. If you have any other queries, you can post them in the Telegram group. The link is available to everyone, so we can discuss more on it. So any other queries, you can post right now. So that's all for today's session, and thanks to everyone. If you need more discussion on this, we will continue.